hear me? All right. The session you're in, we'll try that again. The session you are in is Configuration Manager 2012, streamlining it, and then taking your OSD from a project into business as usual. With me today are Troy Martin, a principal consultant at 1E, as well as Mike Terrell, a systems management practice lead for 1E Consultancy. So everything you're seeing today is things that we have done in the real world and everything that we've learned and we're trying to share back to the community. So as we talk about the session, we always have a lot of questions when we talk about operating system deployments. Specifically, how do I do this? I want all of these things. And OSD migrations, after I got my CM infrastructure working, I still need to put everything else on top of it. All too frequently, we see environments where the CM infrastructure is just barely good enough to handle software distributions, and yet not good enough to handle OSD at the same time. We always want to make sure you streamline it and effectively use your environment, your network, and all the infrastructure available. And then the bottom one is, everybody does it in their lab, and it works perfectly, but you still need to scale it up, not just from 1 to 2, but thousands at a time. And we'll talk about a couple examples where we did 10,000 machines in a day, that kind of fun number. So we always talk about wanting the easy button, and we have all of these wonderful solutions and tools we provide to each other. But at the end of the day, if we don't do it quite right with the 80-20 rule, we end up spending all of our time just making the easy button work for somebody else. And if you're like me, I actually want the easy button from time to time. So what we need is a CM infrastructure that is efficient, very effective, low maintenance, right-sized. It's kind of a good term, but basically we want to make sure we have an environment that handles everything we need, but doesn't make us handle it. We've all had to do the Service Pack 1 or the CU1 update for different projects and products, and the change management is just a monster. And it always takes way longer than you think, and it's months and months and months. But that's only because your environment's huge. If it was a little bit smaller or right-sized, it'd be a lot easier to achieve. And with your OS deployments, you need it to be fast enough, you need it to be timely enough, you need to be able to make sure that you hit your SLAs, that your end users aren't down, that you back up their user states, that you're able to not impact the network. Basically, the user wants to kick it off themselves and then show up 2 hours later and have everything done. And we need to be able to do that without having a project with project managers, interns running around to their systems, figuring out what's installed, and all those problems we run into continuously. And we're going to talk through how to basically automate this stuff. So one of the things that 1E has been proposing, or actually been following, is from Forrester. Specifically, they hit 5 things about priorities in IT. The top 3 are basically, use what you have and do it better for cheaper. And the 4th one is, not only do you use what you have, but use what you have intelligently to achieve what you need to do. If you guys haven't run into Forrester before, their entire motto is find out as much as possible, distill it down, and give it back to you so you know what you need to do. And the last one, the 5th one is, and this is always obvious, you don't have any more, get more done. And that's basically the motto of IT. How much can we get done without spending or doing any more? So the problem that we see frequently from 1E is us, the IT departments, are very, very good at putting in place solutions and configuring it and making sure we have roadmaps and SLAs and we hit everything. But the business doesn't talk like that. In fact, it doesn't even think like that. Their job is to deliver whatever the product is as quickly as possible and efficiently as possible, and they use a completely different language than we do. So what 1E has been putting together is something called active efficiency, where we've all run into the people who can communicate to business and IT at the same time. And we're trying to make that more formalized, and we're doing a really good job of that. And we have some great tools to actually make your job easier, because we all know that most management wants to know what's going on. They don't want to know the details about how it gets done. And this will help you achieve that while also getting it done. Both. You need both. So what we're talking about is creating an efficiency platform to actually make our lives more efficient, getting more done with less. All those numbers from the Forrester study. Gartner has another one very similar. And then at the end of it, creating a career path. Don't worry, we're talking a lot about technology today, but you do need to be able to communicate both at the same time. And we've all seen the people who are in IT who are able to speak really accelerate their careers and usually end up in executive level management and then leave all of us to figure out what they just did. It happens. So we're trying to make it the entire silo from the top down be successful. So as I was mentioning earlier, automating the 80-20 rule, basically automating the 80, then work on the 20 afterwards, because we all know that we want to do more. There's always that other project. We always want to get there to save time, to make happier users with no disruption or any real extra work. We all want to actually do the 40-hour work week. Speaking of which, how many people here actually work 40 hours?
Only 40 hours?
Yeah. I want to work for your company? No, just kidding. It's rare to see. I mean, it really is rare. So the agenda today is to make sure we work on our CM 2007 environments, which makes it much easier to go to 2012, as well as making our 2012 infrastructures easier to use. And then also for our OSD task sequences, we're going to take on two of the biggest problems today when we're doing deployments. User state migration on remote sites without having to create all kinds of state migration points or data shares or DFSs. How do you do that dynamically, easily, without any extra hardware? And also, hard drive encryption. Another great question. Who here has got full drive hardware encryption? How many people here have had problems rebuilding or building machines with OSD? Yeah, that's why we're covering it. And the last one is application rationalization and mapping, which is a really fun, long word to say, but it really means figuring out what you have, adding on usage, and then mapping it, how we define it, based on that usage, so we get the right apps to the right people at the right time. Kind of a base level. You've seen CM, you've used it in your environment, that's pretty much it. Same stuff we've been doing every day. What we're going to be working with is on that base level of CM 2012 and MDT, we're going to be adding in 3 products from 1E. The first one is shopping, which allows end-user self-service and that app mapping I mentioned. The second one is app clarity, which gives you rationalization, utilization, all that kind of fun stuff. Not just on a global scale, but per application without having to add any software metering rules, which is always nice. And the third one is Nomad, which is to right-size the environment. In the lab we're doing today, we're going to be having our base infrastructure, which has your AD, your domain controller, your configuration manager server, and 2 subnets with clients on each, including some bare metal clients. We're going to be adding in Nomad on the distribution point, on the console, as well as Nomad clients, because you need to be able to do bandwidth utilization, and Mike's going to talk about all that, as well as a active efficiency server, that bridge we talked about earlier, the ability to do more automated tasks while at the same time achieving more with it. And on that server, part and parcel, we'll be adding the app clarity and shopping components. And we'll talk through all these in a bit. So at this point, I'm going to hand it off to Mike, and he is going to talk a bit about design with 1E Nomad.
Thanks, Sean. So just a quick show of hands, how many people are running Config Manager 12 today? Okay. How many of you are familiar with Nomad, our Nomad product? Okay, fair bit. Good. So we'll quickly discuss a couple concepts and features around Nomad for those of you not familiar with it. We have a couple of patented technologies that we use for transferring bandwidth that we call reverse QoS. There's also the concepts of elections, peer resiliency, work rates, cache management. Basically, how it works is Nomad grabs the content from a distribution point if it's the first one in a remote location. The way it does this is it dynamically selects the best machine out of the machines targeted to grab that content. No extra administrative effort is required in this case, unlike if you were to use a branch distribution point or a remote distribution point, you'd have to select those machines. Nomad just does this all automatically for you in the background. The other thing we use is a complex algorithm known as reverse QoS to actually grab the content across that wide area network link, ensuring that we never interfere with critical business traffic. We also use proven protocols and technologies such as SMB, HTTP, and HTTPS. No custom protocols or anything that requires any additional setup. Once the content gets down, it then serves it up to peers on the same network. This has a drastic speed to deploy the content out there because now you're not using all of your bandwidth with dozens and dozens of clients actually going across the wide area network link to get that content. You get it down once intelligently and then serve it up rapidly. In the event that the master does go offline, we actually have a failover mechanism that's seamless and happens within seconds. We also have a consistency checking process to prevent any kind of man-in-the-middle attacks. So it's kind of like an extra layer of security to Config Manager itself. We do our own hash checking to prevent this. And then once it's handed back to the CM client does its own hash checking as well. I'll give you a basic idea of the Nomad data flow. Here we have an office with 5 PCs and a subnet. And they check for policy. We happen to target Microsoft Visio. What happens next is an election occurs, and the best system is selected to download that content from the distribution point. This is based on a number of factors, such as availability, whether it's already got the content, performance. What happens next is it downloads the content using our patented reverse QoS technology over the WAN while serving it up to the peer clients. In the event that that system goes offline, within seconds, another election occurs, and the next best system picks up where it left off. It doesn't start all over. It resumes instantly, downloading using reverse QoS and then serving up to the other systems. Now I'm going to turn it over to Troy Martin to talk about some of our new features in Nomad.
Thanks, Mike. So the concept of a fan out. Fan out is a new feature in Nomad 2012 we're very excited about. And it came about from the goal of how can we accelerate the number of concurrent deployments that you can do, whether it be software distribution, software updates, or OS deployments. Native in Nomad, concurrently, we support up to 6 concurrent connections to a master. But fan out gives us a way to do a many-to-many communication method between clients on the local subnet. And what, what fan out uses algorithmically is more efficient than any other linear topologies, as well as any daisy chaining that some other products use. Instead of backing off, what fan out actually does is, and when I talk about backing off, what I mean is a Nomad peer, if in fact it tries to download content from a master, and it's the 7th one, all right, what it will do is Nomad will actually wait, all right, wait for the 7th one. Sorry, let me back up for a second. In normal peer-to-peer, what happens is when a client is needing content and it's the 7th machine connecting to a master, it effectively, without fan out, it'll wait until a connection is freed up on the master. Well, with fan out, what it does is it says, okay, 6 machines are already connected to the master, so let me force an election on the local subnet for one of those 6 machines and let me download content from him based on the percentage that I need. So now it basically perpetuates the process. And so, for example, maybe the 6 were downloading 10, they had up to 10% of the content. But that 7th machine has 0. So the election is, what machines have more than 0% of that content? And let me grab content from them. And then that process goes on for 6 other machines connected to it, and then 6 others connected to it. All of this happening on the same subnet. And this illustration on the right kind of represents what a fan looks like, and that's where we get the term around a fan-out process. Devices respond to a fan-out request if they meet certain criteria. So if I'm a fan-out peer connected to a master downloading content, example is one of these machines over here, as long as I'm downloading content from a master represented in the red icon, and I have the percentage of content that the other peer was waiting for or was requesting, then I can serve content to other machines beyond just from the master. So here's an illustration that represents the fan-out process. So here we have a master downloading content from a distribution point, and he downloads his content and he fans it out to the rest of the machines on the subnet. So this is a subnet illustration. This is what happens on multiple subnets in your environment. So if you have an environment or a location that has multiple subnets, fan-out is working in this manner, where 6 machines are pulling content from the master here, and then 6 machines are connecting to other 6 connecting to another 6, etc. And again, that aids in accelerating the deployment process. The other feature we're very proud of is single site download. And the goal of single site download is to flatten and remove complexity from your network infrastructure by grouping your sites and locations in a logical format, all right? And natively, what we do is we have an API, public API that is hosted on our Active Efficiency web service, okay? And in that web service, you can easily consume subnet and site information from Active Directory or other third-party sources like CSV files, networking tools, etc. And that API can be consumed by any other tool, script, third-party utility, etc. No separate consoles for Active Efficiency, because really it's the agents, the Nomad agents that reside everywhere you have a config manager client, you have a Nomad agent there. And the agents populate and upload their subnet information and what locations they're connected to, uploads that to the Active Efficiency web service, and then ultimately stored in the AE database. So no consoles, all this is dynamic. All you have to do is deploy the Nomad agent, and it handles everything from that point forward. The SSD actually augments the election process, okay? And effectively what that does is, for SSD, think of the concept of a single site download. So if you have multiple subnets or multiple floors at a location, okay, the way Nomad works is let's say there's an election. Let's say it's Patch Tuesday. Let me give you a real world scenario. Say it's Patch Tuesday, and you're deploying a mandatory advertisement to patch everybody at 2 a.m. in the morning. And you're targeting a location that has 4 subnets on it. What Nomad actually does is one machine on each subnet will do an election to see if the content already exists on its subnet. Now, if it doesn't, what it'll do is they'll hold an election across multiple floors or multiple subnets to find out, is there a site master representing the entire location? Okay? And I'll go into that with an illustration shortly after. Excuse me. In that SSD process, when they hold the election for downloading content based on a site master, we actually leverage and query our Active Efficiency web service to determine who are the other subnets at my location or peers at those subnets that may have the content that I need. All right. SSD, the technology is really built to be very redundant and fault tolerant, eliminating any type of single points of failure. Okay. So very reliable process here. And SSD runs in 4 modes of operation. So off, consume, provide, and consume and provide. Where you would use a consume only, what that is I'm only going to connect to a SSD peer and download content from them should I need packaged content. But I will never host content and serve it up to the rest of the environment or floors within my building. Provide means just the opposite. I'm only serving out content. I'm not hosting. I'm not ever going to participate in obtaining content from someone else. So real world scenario there would be like, let's say you have payment centers where you have kiosk machines. They're always up and running, lots of disk space. That would be a scenario where you would have a provide only. And consume and provide, of course, is a scenario where you have the full OS running, and that's really a standard configuration. The other scenario where you would just do a consume only is during an OS deployment. Nomad runs under Windows PE. So the same functionality that Nomad provides you in the full OS, you get the same exact functionality running under Windows PE. Okay? And, yeah, I'm sorry? That's awesome. Excellent. Brian said that was awesome. But under Windows PE, I don't want a PE host, or a machine going through its Windows 7 migration to provide content, because that machine is going to be going through a number of iterations of reboots and going offline, etc. So very customizable. So let's go through an illustration of how SSD works. So we have here a building or location, and that building location has 3 floors. And there was an election that took place for a mandatory advertisement where this machine became the site master for all the floors in the building. And as he shares his content for the site masters or the subnet masters on the other floors, then those subnet masters use normal Nomad P2P or peer-to-peer to share the content with the other machines in the environment. Again, I want to emphasize this is a single download of the one content that all these machines need. Extremely efficient, absolutely in line with our goal for eliminating network waste. All right, I'm going to turn this back over to Mike.
Okay.
Stop fighting me. There you go.
Okay, so you're probably wondering.
Sorry about that.
Go forward. Okay. It's work. Okay. So you're probably wondering what kind of impact can this have to my overall hierarchy? If you had an existing 2007 infrastructure and you had servers scattered throughout your network in tons of different locations, you can eliminate all of that with Nomad. Going to 2012, or if you already have a 2012 infrastructure in place, you can reduce all that. But in the event that you're actually going through a migration, you can actually speed up your migration by eliminating tons of servers out of your environment. There's a time factor involved when getting servers. You have to procure them. You have to get network space. You have to get rack space. And that can just drag on the process of getting your project off the ground and going. So by eliminating all of that, you reduce that, and you can get up to CM12 as quickly as possible. Now, you're probably wondering, how does this actually look in the real world? You know, what's a tangible real-world example? And we like to use the phrase, designed for big, small, and everything in between. So whether you're a 1,000-seat shop, a 10,000-seat shop, 100,000 or more, it all applies the same. So for my current project, which happens to be a 450,000-seat global environment, this is what we're currently using. One CAS, 9 primaries, one which is actually just used for discovery and fallback site for site assignment. 0 secondary sites, not needed. Total of 31 distribution points. Now, if you use the standard Microsoft guidelines of 1 DP to 4,000 clients, that's roughly about 124,000 clients that you can serve, not taking into account network factors. So that's just a fast connected network. Chances are you got locations all over the place, which actually will require hundreds, if not thousands, of distribution points. So it has an overall huge impact. I'd like to introduce Brian Mason. He's a Convict Manager MVP. He also runs the System Center user group out of Minnesota. He's very active in the community space. You may have heard his name or read his name in a forum on TechNet or MIT forum somewhere. I'll turn it over to you, Brian.
So this on? Hello. So I work for Wells Fargo, and I got to tell you right now that the views I say aren't necessarily those of Wells Fargo. All right, with that out of the way, I'd like to thank 1E for making Nomad because in 2002 I used to play server janitor. My job was to get on servers and reinstall secondary sites all day, clean up disk space, put in work orders for hard drives that are shot, and I did that for like 6 months, and that was really fun. And then when they invented Nomad and we actually got it, I got so much time freed up I could become an MVP, so thanks. So what I want to talk about today is just how we can consolidate and keep a small infrastructure with using Nomad. This is my design here in CM07. We have 368,000 clients. I have 3 primaries. Each primary has 4 MPs off of it. And then 6 DPs right now. This serves us pretty well. It's pretty small. That's all it takes to manage 368,000 clients. That means less work for us. When patching comes up, this is easier to manage. CRs, upgrades, updates, everything. This is easier to manage when you're that thin. But we can do better. Let me show you what a DP looks like. Can you next me? This is a real screenshot of one of my DPs for just like a week ago, maybe, I think it was. You see the last date, there's 3:30, so I guess it was on the 30th. That's what one of my DPs look like today, because I have Nomad, so nobody's using them. So we get little spikes of traffic, as we do, big distributions or software updates and stuff, but they're just spikes that come so fast, and Nomad works so quickly that, You know, one guy's in per subnet, and that's it, and it goes. So what a big waste, right? Mr. Efficient, 50 servers. I can do better than that. Show the next slide. So this is my CM12 design. Come on, is that sexy or what? This is amazing, because what I'm going to do is mix my DP and MP roles now. And I still have 3 primary sites. That's just, I have so many clients, I can't get that down any more than that. I do have to have a CAS. That's just our site thing. But knowing what Nomad was able to do before, we can still do better, and I'm looking forward to doing this. We just got our CM12 equipment racked. It's on server 2012. We're installing CM12, and we're migrating in a month or 2, so I'm excited to see this in action. And when we do it, we're going to flip on that free fan-out switch and see just how much more we can get out of that. Maybe I can even knock off a couple more MPs off of this and get it even thinner. We'll see. I'll let you know. That's all I had.
Thanks, Brian. So just in the summary, thank you very much. Just in summary, we showed you a tool that allows you to, streamline your environment for 368,000 machines, total of 15, 16 servers, not including reporting. Yeah, we're not talking about fluff for marketing. We're actually saying we're doing this, we've done this, we're repeating this over and over again. It works out pretty well. So we've covered streamlining the environment a bit to make your lives easier. Next, we're going to jump into some task sequence engineering. Specifically, how do I achieve the following things? How do I do USMT backups on a subnet? How do I actually deal with hard drive encryption? Having a little trouble talking here at the moment. Too much sugar. So next up, I'm going to hand it off to Troy Martin, and he's going to take us through
Task sequence engineering.
Excellent.
So set the stage here. You're probably wondering, okay, all this reduced infrastructure, roll back DPs, roll back Pixie service points. What about user data during OS deployments? Do I still need my state migration points? And the answer is no. Right? You can even roll back your SMPs. Okay. So how do you do this? Let's take, for example, a serverless environment. And doing an OS deployment, what do you do with the user state data? So these are a couple of key points we want to cover, but primarily we want to focus on not only using Nomad and the Nomad cache and using available cat or disk space on clients to store package content, but actually using Nomad to actually host USMT captured data dynamically live during an OS deployment. So here we have a serverless environment. We got an office with a user that decides to migrate their OS or their machine from Windows XP to Windows 7. And this is driven, let's say they went out to our shopping website and they shopped for a new Windows 7 deployment. The deployment runs on the machine, the task sequence is executing, and during that task sequence execution, Nomad is running in the background and kicks off an election on that local subnet to say, I've actually estimated that there's 2 gigs of disk space, 2 gigs of user data being hosted on this old Windows XP machine. Are there any other Nomad clients on the subnet that can actually host this user state data, these 2 gigs of user state data? Now you say, well, if I'm doing a refresh, I can use hard links, things like that. Of course. So this is primarily has to do with scenarios where you actually have to move the data off the drive. So for example, hard disk encryption, full disk encryption situations. Let's say, old XP legacy is that a lot of people would have multiple partitions, multiple drives on a system, right? So they want to use the refresh as an opportunity to kind of revert that back and have a single partition, right? In those scenarios, you have to offload the user state data off that machine. So the election takes place. This machine says, hey, I can host that data for you. I have at least 2 gigs of available cache within Nomad. The Windows XP machine says, great, I'll move and copy my data over to you. The new OS is applied, is now migrated to Windows 7. Now it's in the state restore phase. It gets to restoring or running load state to restore the user data. And the user data, it forces an election on the subnet, and the user data goes back to the Windows 7 machine, restoring the profile, the personalization, as well as all the user data itself. And I kind of spoke ahead of myself, but that's effectively what happens there. And again, keeping in line with our goal to diligently make sure we're eliminating network waste. All of that happened without any data traversing the WAN. All happens locally, dynamically. And all this is configured on the Nomad clients during setup, during installation. No one's in the back room, making this happen behind the scenes. Yes?
What happens if that machine goes down, turned off?
Very good. And there's certain laws of physics that Nomad cannot overcome, right? So if that machine goes down, then yes, we have to get that data back. But we build redundancy into the task sequence process so that you can you can have multiple machines that you back up to. Okay? So I can back up user data to more than just one machine. And I can guarantee that only one machine will have an instance of that user's data. If I have 3 steps I add to the task sequence to run this 3 times so that I can have redundancy, then one machine will get it, another machine will have it, and then a third machine will have it. So, good question, very good question. Nomad does not, it's like the mailman. He's just delivering. He doesn't know what's in the package, doesn't care what's in the package. Encryption, you get that through USMT, right? Where you're passing on through the scan state command line encrypted. That's where you get the encryption. All we're doing, sorry? Of course, right. As part of your strategy for USMT, you would have to turn that switch on. But all we're doing is hosting the data temporarily so that the OS deployment can occur. All right. So here's a kind of a flowchart illustration of what I just described. OS deployment begins. User state data is estimated, 2 gigs of data for this example. Nomad initiates a poll on the subnet to say who can host that 2 gigs of data. Once the machine answers and responds, the user data is copied to a host. To round out that transaction, the machine being migrated, the XP machine, issues a complete to the host that has the user state data. It says, hey, I'm finished copying the data to you. Machine continues, the task sequence continues, the machine is migrated or Windows 7 is deployed to it. Now we're in the state restore phase, and now it's time to find out who actually has that data, okay? And he issues an election on the subnet to say, hey, what machine has the data for when it was under the Windows XP naming? A machine answers that election, the one that was hosting it. The now Windows 7 machine connects to the host, retrieves the data, rounds out the transaction by now retiring the data on that machine and basically deleting it. Again, all of this happening dynamically, no magic or anything like that. It's just the agents talking to one another and handling all the dynamics beyond around making this successful.
Is all that logged?
I'm sorry?
Is all that logged?
Yes, in the Nomad, we have several Nomad logs that basically monitor all of that. Absolutely.
What if migration files too big? So say you have a 10 gig migration file. Is it going to try 2 gig, fail, move on to another election, find another machine that has enough space? Is it going to split it up? How does all that work?
Very, very good question, Chris. So when you're actually configuring Nomad to be deployed to your environment, you got to do some upfront homework, right? To estimate what is the average amount of disk space, or size of user state data that we have in the environment. We have scripts and things like that can help with that effort. So you want to find out average user disk space or average user data in profiles is X gigs. Let's just say it's 2 gigs. But you encounter a user that has 10. So some of the things you can do is when you're configuring Nomad, you can dynamically adjust Nomad, right, using settings management or some other capabilities to provide that automation. Dynamically determine if you have a disk drive that's 250 gigs, 150 gigs, whatever, then I want to allocate Peer Backup Assistant, which is the feature I'm talking about. I want to have that configured to host more disk space. So the standard across the board is 2 gigs, let's just say. But maybe I have machines that can host 10. So I'll configure that within the Nomad installation. All right. So it's all about dynamically figuring out how much disk space a machine has and then calculating based on that how many instances of 2 gigs, of 10 gigs of disk space that it can hold. Now, to answer your question, that wouldn't happen if the election that would go out to the subnet is who can host 10 gigs of disk space. A machine that cannot host 10 gigs of disk space or less than that would never respond to the election. So only machines that are capable of handling it will respond. Now, if no machines on the subnet are capable of hosting that data, then we have capabilities, again, making the task sequence more intelligent. We basically instruct the task sequence, fail the deployment, because we want to fail safe. I don't want to continue the deployment, and I don't have anywhere to host the data. So we fail the deployment. If the deployment fails, that information is rolled up within CM status messages into the site, and there's a number of reports there that you can kind of drill down into to determine what actually happened. Yes?
You say you set that up dynamically, or you can go back to the fail-safe hard coding where you want to store it.
Absolutely. Yes, absolutely. Very good. So you can rely on Nomad to handle all of that dynamically, but maybe you have machines that, you know what, I know Nomad can handle it dynamically, but I actually want to actually target and use specific servers, or maybe you have a kiosk, or any one of the above. You can hard code that through collection variables, machine variables, MDT database. There's a number of different ways where you can tell Nomad, go and host the data to this location. I don't want you to do it dynamically. I want to know where it's going.
Dynamically, if there's no machine that can do it, can you then fail back
to another machine? Again, it's all about the intelligence of the task sequence. So absolutely, if you can script it, you can put in that logic in the task sequence, we can do it. All right? Yep. So we're going to go into a demo now just to kind of review. Oh, whoops. Just to review the actual, you got to switch me over to 3. Thank you. I'm going to review for you what an actual peer backup assistant task sequence looks like within the OS deployment. So what we have here is an extract of the task sequence steps that would be normally in your single deployment task sequence. Okay? But for illustration and to keep it simple, I just extracted it out and put it in its own task sequence. So here we have a capture user state task sequence. So this would be used in a replace scenario where, the user is getting a new machine. We're going to retire or decommission their existing machine. But before we do that, we got to get their data off. Okay? So what we do is we have an advertisement. We'll target the old Windows XP machine, capture the user data, and then we'll offload it, and during that process, it'll be offloaded to a peer. So let's talk about how that actually occurs, or review it within the task sequence. So I'm going to skip these couple right here, because this is just standard MDT stuff here. But within the Nomad section, what we define here is, first thing as I described, think back to that flowchart example that I had up there. We want to estimate the amount of disk space on the machine. We want to know the size that we need to back up or store before we progress on. So we run a ZTI user estimate VB script from the MDT toolkit. We do a poll on the subnet where we execute Nomad and say, hey, run this poll. Go find for me a machine that can host 2 gigs of disk space for this particular machine. Okay, very good question. TSMV2 is a 1E utility. How many of y'all are familiar with TSMV2? Okay. It's a 1E utility that allows us to modify read-only variables in an OSD deployment. So very handy. And if it's read-only, you would think I can't change it. Well, we wrote a tool that allows you to change that. All right. So essentially what this command is doing is it's finding a host on the subnet who can host the content, and then we pipe that information into an OSD variable. Once we find a host that can store the data, the user state data, we store that information into this Nomad property called NMDS remote. Effectively, what that is the computer name of the peer machine on the subnet that has said, hey, I can store that 2 gigs of data for you. We then initialize the OSD state store path with the value of that host machine. Now that we have everything we need, we know how much data we have captured. We have a host who can host it. Now we just let USMT run and run scan state. And then the data is eventually copied over to that host simultaneously as scan state runs. And then finally, we round out everything by issuing an NMDS complete to basically let that host machine know, hey, I'm finished copying. So we're done communicating with each other. All right, so that's for a capture. So now you've got the user's data out there. You've backed it up safely. And now we're giving them their new machine, and maybe you have system integrators or desktop support maybe built the machine in the back room somewhere because we want to limit the desk side visit and keep the user working. So we built the machine ahead of time, and now we're showing up to their desk with a new Windows 7 machine. And we advertise to the new Windows 7 machine the restore user state task sequence. And effectively what this does is basically the same thing as the capture, but calling different Nomad APIs. So again, now we need to find the Nomad machine that has the old computer's data captured on it. That's this NMDS find. We initialize the OSD state store path to the computer name of the host that has it. Let USMT run, basically in state restore phase. We run load state. User data is restored to the machine, profile, personality, etc. And then we round out the transaction by making sure the data is deleted off of that host machine.
How do you know the old computer name?
It's not the old computer. It was the way we know the old computer name, again, it's about collection variables if we wanted to use that. If we wanted to create computer variables, or we can use an MDT database to actually store that information dynamically. We can have it, one second. We can have that information written to a database, and that information is gathered during when the gather step runs. We can actually store that as an OSD variable. We're actually doing this at a customer now, where they wanted to be able to store that information associated with a machine that we've already provisioned in the MDT database. Yes.
Well, I'm just curious to continue that one. You're doing like 20 or 30 deployments on one subnet.
Mm-hmm.
How do you make sure that the person's getting the right user state back to the right machine?
Good question. The election process handles that. So in the NMDS,
Right, but how do we know, like you said, you send out desktop support or something, and you pull the 30 XP machines out and you put 30 Windows 7 machines at night while the users are gone.
mm-hmm.
So now how do you know which machine was where and which one's going to get the new stuff?
That's logistics, right? That's planning. As I said earlier, we report on the information that Nomad is doing and what hosts are actually storing data. We can actually inventory from a hardware inventory. We know in the registry what hosts are being stored, how many instances of data is stored on the machine. So we can report on this information before you do your deployment. Again, this doesn't eliminate the logistical side of things, right? You still have to do the effort of the upfront planning. I want to know that at this location, I'm targeting these 20 machines. You know, I'm not going to just go out and start ripping out machines. I want to know ahead of time who I'm actually deploying to. So there's both. I mean, we're automating as much as we can where it makes sense, but there's still some effort on your part to make sure you do your homework to know who you're targeting for your deployments. Yes?
Just wanted to add to that. Config Manager tracks all that as part of OSD with or without Nomad.
Absolutely.
And within the MDT integration and the USMT, the computer is represented with a GUID, and there's an encryption key that goes with that.
Mm-hmm.
So if you tried to hack it and restore a profile to a different computer, it wouldn't have the encryption key anyway to
Not every Nomad, though, would have that encryption key.
Say that again?
Nomad uses USMT. Yeah, but
No, Nomad doesn't use USMT, no.
But USMT does the encryption,
Yes.
encryption with or without Nomad.
And
supply the key.
right,
Yeah.
and the key, we can store the key in the MDT database. This is one of the things we're actually doing with the customer. So, and normally if you had a state migration point, that would store the key. So obviously we're making up the difference for that, right? So we have customizations to actually handle that.
So keep in mind, we're still using USMT. We're just making it really easy to set a place where you store the data. And then for recovery, you just do the find step, which Troy talked about a moment ago, and you find the data again. As for your point about whether or not you use certain machines and the logistics, Troy's absolutely right. But also keep in mind, you can turn off machines so they don't respond back to host data. You can put your new machines down and then wait for a later, and you can actually use a separate task sequence to restore data at a later point. Lots of options.
That's it.
Okay. How many people are doing OSD with third-party disk encryption today? How many are doing zero touch with that process, or would like to do zero touch with that process? Yeah, okay. Yeah, with security being at the top of everyone's minds, disk encryption, unfortunately, is here to stay, and it's not going away anytime soon. The third-party vendors often make it difficult, and until recently, they really didn't care about OSD until customers such as yourself started beating on them and complaining about the process. But it makes it difficult if you want to migrate away from that platform and leverage something like BitLocker. They make it extremely hard to do that. So they want you to continue using their tools going forward. So another product that we didn't mention that comes with Nomad is a product called Pixie Everywhere. How many of you are using Pixie booting in your environment to deploy operating systems? Okay, for a number of hands. So we had this customer that had a need to do zero-touch OSD with third-party disk encryption. And when they got around to their OSD project, they realized that they had lost the password keys for their hard drive encryption. So this was going to be very time-consuming and laborious effort, sending technicians or hiring technicians in to go out to every single computer to roll it over to Windows 7. So we sat down and we kind of thought about this a little bit, and we said, well, we've got a lot of tools and utilities. What kind of magic can we create? What kind of process can we create? Can we actually solve this problem with what we have today? So basically, we came up with a relatively simple concept using Nomad, Peer Backup Assistant, and Pixie Everywhere. Basically, it is a result of two task sequences. You can't combine it down to one task sequence. You just have to make sure you put the necessary logic in that task sequence to be able to handle the machine when it's in different states. Flipping the boot order after you capture the user data so that when on the next reboot, it actually attempts to Pixie boot instead of booting from the hard drive. What that does is it basically treats it like a bare metal build at that point in time. So to illustrate this visually, what it looks like is you target the first task sequence to the device. Now this task sequence would be one just like Troy got done illustrating, with the extra pieces in there to actually flip that boot order. So if you're using Dells, they use the CCTK to actually set the BIOS settings to where you can manipulate it and move Pixie booting to the top of the boot order. After the data is backed up, we flip that boot order, and then we proceed to target the second task sequence to that device. So the second task sequence would be the main OS deployment task sequence, which would do the work of deploying the image. It could be the same one that you're using for your existing bare metal deployments. If you're just bringing boxes in from an OEM and putting the corporate image on, or maybe you have a replacement hard drive that goes in that's not formatted. After the system reboots, it Pixie boots and then runs a mandatory or required OS deployment. Applies the new operating system, and then in the logic you would add the necessary steps to actually toggle that boot order back, pushing, either disabling Pixie boot or just moving it down lower in the boot order. Once again, no data transferred over the wide area network, and being able to actually achieve zero touch with hard disk encryption. Thanks. So this is the basic flow. I won't go into the details, but one thing new that I wanted to point out is you have the ability to make deployment 2 only available to Pixie boot media. So chances are you're probably very cautious about just targeting systems for OSD for a good reason. So in Config Manager 2012 SP1, they've added in this new feature here where you can actually target a deployment to just boot media and Pixie, and you can make it hidden. So what this effectively does is gives you an extra fail-safe so that you'll never target a device that's unintentional. So you can set up the provisioning early on it will never process that advertisement until it actually reboots and pixie boots for the first time. So we talked about a couple different methods for saving user state data, pixie booting, transferring content intelligently throughout the network, including OSD content, but we haven't talked about application rationalization and mapping. So end users need to get their applications back, and I'm going to turn it over to Sean to talk about that.
Thanks. All right, you guys all good so far? Did some nice things with task sequence engineering. We've done some streamlining. Now we're going to talk about making our lives a little bit easier with rationalization. What we're really meaning is we have software in our environment. We need to figure out what it is. We've all seen the hardware inventory, the file inventory, all the different rules, and the 1,000 different products that all do it, but very few of them do it very well. What we have from 1E is something called app clarity. And that pie chart on the right is an example for an application where we figured out how many installs there are, and then we broke it down by usage. So not only do you know what's in your environment, but you can actually figure out what you need. And then with usage, you can start handling version sprawl. What I mean is, how often have you heard an end user say, yeah, you can take the software away from my cold dead hands, or I need that because this person needs it. Have you ever used it? No idea what it is. And you get that all the time. And then every time you rebuild an operating system, you do the wonderful phrase of, well, I want what I had. I don't care what works. I just want what I had. I don't care what I use. I want what I had. And you can fight that with knowledge. And that's what we're going to talk about. And the last thing down there is how does the end user figure this out? How do they actually be able to look at what they have, ask for more, rebuild their machine with the right apps, and then if they missed anything, go get it. We'll talk about that. So this first slide is about the rationalization. And yeah, it took a long time to find all those Adobe icons, but we got them together. What we do is we take all that hardware inventory and we pass it through 3 different layers, trying to filter out the noise, all the patches, all the security files, all the little plugins that come with it that aren't the actual application. And then we break it down to the publisher, and then the product, and then the version. And we'll see that in the demo in just a couple seconds. And with all that filtering, we also do license information. So you can figure out if it costs a lot, and you can enter in your information. That can be done programmatically or through import wizards, or even through the API. So you can actually import information from your own systems into here and get a nice, quick view. So once you have your rationalization, which this covers on here, we have to then begin to start using it. And one of the nice things about the rationalization, and this is where other things kind of fell down, is we also sync up with the cloud. Well, our cloud. Yeah, we have to say the word cloud. What we're really meaning is you synchronize your catalog with the one we provide, so you constantly have the up-to-date information, which is, rather nice. I don't have to do it. Everything I have is anonymized, so you're good. So the last part we're going to talk about now is the self-service portal integration. This is the app mapping part of it, where we have information of what's installed. We've rationalized it. We added usage, and then we need to actually start migrating the users. So as an example, let's say we have a Windows XP machine. It has Visio 2007 Professional, and we're going to put it through our process. The goal is to put it to Windows 7 and get the right apps. But one last thing, automatically. Sure, there's a little bit of upfront work, and we'll walk through that with the app clarity and shopping solution. But we want to make sure that we can just put any machine or any number of machines or any thousands of machines, you see where I'm going with this, and then give it the right applications. So if we have Visio 2007, and let's say they've used it once in the past 90 days, most likely they need Visio Viewer. And so we'll give them Visio Viewer on the back end. And that mapping, we define. We control the packages, we publish the packages, and then we control where it goes to. It may not be perfect, but with shopping in the back end, they can go back and get something else with approval. So how does all that work in the back end? Well, visually, your clients are constantly giving information to CM. You got all the data right there. You don't need to go out and have another agent. You don't need to do anything else. You have the data. So we harvest that data, pull the information out we need, just little bits of it, rationalize it, give you all the things that you want, and great, we're good to go. You can do that on a schedule. It's very simple. And then one point or another, your user is either going to self-initiate an operating system deployment, or more likely, we're going to advertise out one to them. But either way, the app mapping needs to work in the task sequence. So there you go. What happens is shopping then communicates to app clarity, pulls out the data, the current inventory, not the one that you surveyed 6 months earlier and they may have something completely different by now, but the one that's that day from the last synchronization. put it through the app mapping, and then return that information back to the client in an XML format. And we actually use the native step of install multiple applications in the task sequence. Works great, no extra components. Just call a couple of APIs and you're done. So the next thing we're going to do is actually show you those APIs, which are just web. You're going to love this. What we do for the actual task sequence is we have 2 extra steps. The first one is you have to define what the old machine and domain is, because we need to pull the inventory from AppClarity. So provide that, and it's really simple. It's the machine you're on. Great. Lots of ways of gathering that. We may already have the information because of steps about changing your naming standards, changing the complete name for the machine. That's a process we have to do anyway. So we have the information. Then we populate that domain and machine into the API and update the information we have. Make sure we have the current inventory. From there, we take the information and give it back. We get the filtered applications. And what I mean by filtered is we not only get back the information from shopping and AppClarity, but we want to make sure that we check the CM client that hasn't executed it already. Grab from the HKey local machine, software Microsoft, SMS clients, remote clients, software utilization, execution history. Yeah, I have that memorized. And then grab out those package IDs and don't run them again, just to be sure. Once we have that variable defined with all the right properties, install them. And then from there, tell shopping that you installed them, and so shopping can continue its normal process. And what I mean by that is when you normally shop for any item, we will check to make sure that the client actually exists, see if the GUID's there. Because if the GUID's not there, there may be some process lag, or it's got to filter up your hierarchy if you're not using Nomad, so it's really flat and simple. But you want to make sure that you only add the new advertisements afterwards. Now, what kind of things wouldn't be able to be injected? Well, shopping does AD integration. Maybe you want to add that machine object to an Active Directory group. Or perhaps you have another task sequence, and Microsoft doesn't allow you to insert a task sequence inside of a task sequence. Quite a few scenarios. But we handle all those. So what's next? Let's go see what we're talking about. And what we have, I'll jump back to that in a second, is a client machine that happens to have on here, let's see what we got on here. We have Microsoft Office Visio 2007 Professional. Cool. We've got Adobe Reader 9, which is the bane of most of our upgrades. And we have WinZip, which does exactly the same thing as we've all done forever, which is compress files and send them around. So we'll need to make sure we migrate those 3 apps when we build this machine. And what we're talking about when we talk about shopping, let's go to the shopping homepage, is a very simple to use interface that allows you to see different applications, and we can go do some miscellaneous shopping, like I am a big fan of Angry Birds Space. I know I need the CM Toolkit because I'm going to want to look at logs one day, and we'll proceed to the basket. Now, I'm an administrator logged on here, so I'm able to actually shop for other machines. So if I wanted to shop for, say, PC02, it's a lab environment. We have some complicated names. We can search for that. And we'll just add that one in there. And I know that our administrator over here is going to say, why do I like Angry Birds Space? Because it is better than Rio. Excuse me, English. There we go. And then I can go to the top and I can place my order and go on and go forth. Great. But on the back end, this is what we're really interested in. We have our 1E server, which is that active efficiency server, and it has all that rationalization of information. So let's go open up AppClarity. And we have products, node, there we go. And we're going to go look at Microsoft because Visio is expensive. So we want to go check out what's going on. So we go look at Visio Professional 2007, and we'll notice that there are a couple of machines that have it installed, specifically 2 that have 2007 and 2 of 2010. Now, this is a lab environment, so everything's green. You guys get the idea. In your environment, we're going to have a lot more information, so we'll have a lot more pretty colors of yellows and reds. Now, this machine right here, this one application, has a few other installed, but we're going to take a look at a common unused software report because our lab's kind of small. And you can see the breakdown gives you a lot more great information. It tells you about the applications in your environment, taking the license information, assuming we populate it, and it gives you some total cost savings. This is great for management. They love pie charts, they love color, and they love numbers. But what we really want to know is what applications we're talking about and how many of them we're going to be working with. And you can see from information here, we have it broken down by per device, the number deployed, used, unused, cost, and so on and so forth. Now, this is a great report, but we want to act with this. So what we look at is we can see the different, remember I mentioned rationalization earlier? We can see the different versions we've all put together, made it life easier. And we can also see the specific machines for each application, which that report just said a number. You can actually scroll to the right, and you can do a report, and it'll give back you a comma-separated value. But you can also get the same information if you were to use the APIs, and you can get the information for Visio Professional 2007. Returns it back as an XML, simple web URL. You just have to have rights to see it, so security controlled. And then you can break it down through any tools you want or any reports you want. And we tell you why certain calculations occur, like machines too new, so we can't really calculate it, lab environment limitations. All right. So from there, we have to do a little bit of integration. And a unique identifier is created for each application. And that identifier for Visio 2007 happens to be 7561. And what you would do is you would go into shopping, where you can import applications, but let's say it's a new environment. We want to do a bunch of bulk imports. We can use a wizard here and pull in all kinds of applications, and it'll come in a disabled state, which allows you to define more things. But for the purposes of this demo and for time, we have Visio 2007 Professional, and we're going to take a look at the App Clarity tab. Now, I've pre-populated to save some time, but 7561. Cool. Those are the basics. The next thing we're going to want to do is look at App Clarity rules. Now, remember, we had that machine that had Adobe Reader 9, WinZip 9 on it, as well as Visio Professional 2007. Now, WinZip is not going to be installed no matter what the usage is. But Adobe Reader 9, again, no matter what the usage is going to get Adobe Reader 10X. And on that machine, I happen to know that it's used because we saw that green chart earlier. So we're going to add a new rule in of 7561, and we're going to go to Visio. I love that autocomplete. We're going to mark it for used. Excellent. And we'll create a file. Now, we've created our mapping rule, and we're pretty sure we got it right, but we're going to go check. So another tab right down here, you can go in here, and you can check for a specific machine. And we're going to see what the values are. Now, you'll notice that down here at the bottom, we don't see WinZip, and we do see Adobe Reader 10 populated. But we also see Visio 2007. And that's because it takes a couple seconds for it to refresh. You know, you don't want to make sure you impact your environment. You want to make sure you have good processes. So we, on the back end, do chunks up to, I think it's like 100 machines every couple of seconds, and chunk and chunk and chunk and work your way through it. So if we look at the log at the very bottom, we'll notice it says it's finished updating our OSD mapped items. Excellent. So let's go do that again. PC01. And we now have Visio 2010. What that means is the machine is literally going to install that application, or this 3 applications when they go to the task sequence. And you can pull that information back pretty easily. And let's go see what happens when I get that information, when I refresh that inventory, when I get that information back. So remember, the APIs are very easy to see, and we get the 3 applications we expect to get installed via the task sequence. So these are the steps that are being called in the back end. But the actual task sequence itself on the server, we add in 2 new sequels, which is underneath the, where am I missing it? Here we go. Underneath the execution task phase, we set our 2 packages. We use custom INI, just like everybody else does, because it's a lab environment. You can use dynamic variables. You can use the TS-ENV2, which Troy talked about earlier, to set the variables. And then we call a specific website that refreshes it. So like I was doing in the test report, where it was calling in and it was saying, I'm going to update in a couple seconds, there's a simple web URL with a domain and machine name that will call the same thing, and it'll update it. Great. And we'll scroll down a little bit further into the state restore phase. And here we have our filter out applications. And like I mentioned earlier, make sure we haven't run the package previously. I don't know about you guys, but every so often somebody installs software twice and it's unpredictable. That's the best way to put it. So we avoid it. It's kind of nice that way. Once we have our application variable defined of filtered, we use the default step to dynamically install the applications. Now, you remember that earlier we had that XML that returned back certain values. And those values happen to be the package ID colon the program name, which is the exact version it needs. You don't have to do any interpretation. There is no workarounds here. Everything just kind of figures itself out and works automatically. Now, what's really nice about this whole solution is when we get to the end, we mark it complete, and shopping takes care of the rest. Now, one last fun thing about this. We've been doing this at a lot of customers recently. They've been saving millions of dollars and a lot of hours, because I'm sure everyone here has gotten their CM infrastructure working, very streamlined, have gotten their OSDs working great, and then have been asked, hey, great, can you install all the right applications at the right time whenever I want without me telling you? And yeah, now you can. You have an automated solution that will get you there. And if we miss any applications, like when we were on PC01, I can go and shop for it as an end user and get the application I need. Kind of nice. So jumping back to our demo deck, we go into the one last little neat feature. On the shopping website, you might have seen it on the demo, you can actually set up an OS deployment using your task sequence, locking it down by your security, making sure you have the time set up correctly so only an end user can go. So what they would see is they'd literally click there. You could do free-form text here. You can write anything you want, for everything from saying, don't do this, to please do this, so I don't have to do it for you forcefully later. You can get your apps returned back. The information on the left is a free-form text, so you can put in all the apps that are in your actual core task sequence. Because some people have very fat images, some people have thin images, some people have 15 applications they install in first. The end user kind of needs to know that so they don't have to shop for it again. And on the right, you get the mapped applications that we actually just figured out, all those APIs. The stars refer to how much it's used. 5 stars is a lot used, 1 star is a little used. It makes it pretty easy for the end user. And then from there, you can actually schedule a time, like, say, April 9th at about 5 o'clock, like it is right now. And you can literally go through, set the times, and then it will run at that period of time. The last step, you can put a checkbox in here to make sure they click it. You can write all kinds of things, like make sure you've copied your files up to your network share. Please leave your machine there. You can do anything you want. It's kind of nice that way. But what happens when I click Finish? Say it's in the future sometime. The screen on their landing page changes. It changes to Edit, Cancel, and for me, because I live by my calendar, and I'm sure most of you do as well, update my calendar to remember I scheduled it for that time. Because I'm sure that never happens where somebody forgets that it's going on that night and walks out with their laptop. All those fun things. And that brings us up pretty much to the end of that. Does anyone have any questions? I was going through kind of quick.
How do you handle custom applications, so in-house apps? How do we put them in so we can migrate them as well?
Sure. Well, a custom application would still be picked up by your hardware inventory for CM and would eventually get into App Clarity. In App Clarity, if we don't have it defined, we have a really easy-to-use interface that will actually allow you to define more applications. So you can put in your product, your version, your publisher, your product, and your version. That way you can do it, and you create yourself an integration ID when you do, add it into the mapping rules, and that's it. Pretty straightforward. So not only do we handle all the common ones that you'll see out in the wild, but if you have a packaging team that insists that everything must be exactly the same, no matter what that may be, we'll work through that, and we'll allow you to make sure you can handle all that. And the good news is if they do it, they know what they changed it from, so you should make them have the admin console for App Clarity. Give them only the exact rights they need to go add that stuff in, and then have at it. Any other questions? Yeah, please. Well, hang on. Yes, you can. On the demo environment, I'll jump back to in a second, you'll notice there was one more box in the rules for defining basically line of business. So you can create rules in there. Also, this is not mutually exclusive with any other technologies if you have. So if you've predefined application sets via MDT or something like that, you can do the App Clarity at the end, because remember, we filter out any previously run apps. Go for it. With what?
Can't integrate it with MDT.
I believe we require CM for 2 reasons. One, you need the inventory for what's going on, and the second one is the custom task sequences, and the actual OSD is all integrated in there. Yeah. You could probably do the app mapping calls, but you wouldn't have anything to call.
Yeah, I probably wouldn't use MDT.
Sure. The other flip side is you don't actually require MDT to do all this work, but you could. Now, since all of you have stayed, we have one more thing that we want to demo. Is Paul in there? There he is. Paul Park is a product manager from 1E, and he's going to take you through just one more thing that we got coming out. It's probably going to solve a few more problems that you have.
Thank you. So I'm going to keep this quite brief, but the one more thing is relating to what about BYOD, bring your own device. Now, how many people here, just a show of hands, use a smartphone or a tablet, and they connect to their work networks, pick up their email, look at their calendar, pretty much everybody. The interesting thing is that initiative, you know, a few years ago, people wanted to do that, and a lot of IT departments were against it for all sorts of good reasons. So BYOD has happened almost entirely without the involvement or the approval of IT. We all have tablets, we all have the smartphones. How many of us use those as our primary work device? Do most of our work on it during the day? Nobody. That's interesting, isn't it? Because actually, to do real work, you need a computer, and actually, to do real work, you need Windows, and that's a fact. So what about bringing your own computer? Now, I'm a Mac user, so I've got a shiny MacBook Pro at the back there, and there it is, being held up, modeled by my beautiful assistant. And so it's great. It's a lovely machine. I love using it. It's slick and everything else. But unfortunately, for most of the applications that I access within the organization, and actually even using the Office programs themselves, I don't get the most. I can't work as effectively as I would be able to do so on a Windows machine. So for BYOC, is VDI the solution? Well, if I was an Office-based task-type worker, then maybe it would be. But I'm actually on the road all the time. I'm in the air. I'm traveling around. I carry most of my stuff with me. VDI's got lots and lots of good points for certain type of use cases and certain scenarios, but for mobile workers like me, it's not a good experience. So we looked at this from 1E, and we came up with something very new. We're launching this at MMS, where this is kind of a sneak peek into what we're doing, and we call it 1E Workspace. And so there it is. It's a slightly different take on virtual computing. So, so why 1E Workspace? Why have we done this? Because our idea is that it enables IT departments to give users what they want. By utilizing client-hosted rather than server-hosted virtualization, you can take this offline. So you know, you can connect up to the 1E Workspace site. You can download the virtual PC onto either your PC or your Mac, so it's not just a Mac solution. But get up and running within about 10 minutes. Log in, start using the computer while it is still downloading. But the great news is that download will keep going, and you can take it offline. So when you go out of the hotel room, you get in the air, you've got a PC that you can use. increase user productivity, give them the ability to use their shiny Macs in the office, but have an environment they can also work with at work. And from an IT perspective, we're looking to make this really, really easy to manage and deploy to users anywhere. The ultra-fast OS streaming that can be taken offline means literally getting people up and running within a few minutes. Lowest cost. From an infrastructure perspective, you already have it, because all of the work around setting up these machines, these virtual PCs, will be done straight out of Config Manager. So no competing infrastructure. And the last thing is, you're looking at standing up a corporate desktop on the user's own machine in one of the scenarios for this, so it should be secure. Now, these virtual PCs, you can treat them very much like normal physical PCs, so apply all the same tools, all of the same security policies. We are building into this, and have built into this, AES encryption, so to equal effectively the hard disk encryption that you'd have on a physical machine. So, because you can't stand up a virtual corporate machine on a user's own machine without being able to have the same type of encryption level, including things like remote lock and wipe, and if someone doesn't connect to the network in the time, take that machine off. And that's it. So that was the introduction to One Workspace. I'm very happy we're launching that here at MMS this year. I'll be at the stand. We'll be having a little bit more of a discussion with it at our stand, but thank you very much for that.
Excellent. So that's a sneak peek into where we're going, and it's the short term, not the 20 years in the future of the term. Kind of neat, isn't it? Takes care of all your problems of how do I bring my shiny laptop into the office and get the work done without having to deal with the cathode ray tube monitor and all that giant stuff. Do you have a question back there?
Yeah. So, it's pretty neat technology.
Yep.
Are you looking at implementing a two-factor capability for authentication for that?
I'll defer that to Paul later, but the short version is it's a full operating system. So if you want to change your Gina and use the RSA token key for the two-factor or whatever program you want, it's a full operating system.
Do you mean specifically for the encryption around virtual?
Yeah.
Ah, sorry.
Okay, so initially it will be baked with the password, but effectively that key will be able to be used for other things. So it's part of the program. Okay.
Excellent. All right, quickly sum up, because we're about 30 seconds beyond where we're supposed to be, which is pretty good. Active efficiency, that thing we talked about earlier, that new career path, that ability to actually communicate with the tools like App Clarity and Shopping, you can achieve that. And with Nomad in your environment, it makes it so much simpler, like Brian was talking about and some other examples. And if you want to hear more, come ask us later. We can show you people that are using it today and effectively using it. Not firmware, not thoughtware, not vaporware. Actually today have been for a long time. And at the bottom down here, we always want to say we're the world's first IT efficiency company because we're trying to make this space a little bit better. We're trying to make sure that you get trained in how to do this because it sounds cool to say, I want to do all this stuff, I want to have the tools to do this stuff, but we're also providing certifications and education, really. We've all been trying to do this for so long, and we're now trying to bridge that gap we saw earlier. And the last slide for us is we frequently get asked, how can I join 1E? It's actually a fun question. Everything from our 1E party to intellectual curiosity. We're playing with some of the biggest environments out there. We're also working with some of the neatest tools that are going to solve problems that we're going to run into. And we also want to make sure that we have the subject matter experts. You guys. You guys are the best and the brightest. You're at Microsoft Management Summit to become even better. Those side conversations, all those fun interactions. And we also like to belong to the community. We don't just mean My IT Forum. We mean we sponsor a couple of different orphanages. We've taken kids all the way from basically homelessness to graduating from college. We sponsor all kinds of other things. Employees are allowed to select their own charity, and the company tends to be very generous in matching that. And the last one, of course, is you have to love what you do. You got to be passionate. You got to be driven. You have to actually enjoy this stuff. Now, we all have had days where we work in our cubicle and we just can't believe that there's another client that's broken. But at the same time, we've all had that rush when everything just worked, and everything was because we designed it to do so. And that's what we're talking about. So it's one of those great things. And that is that. Thank you very much, everybody.